This video is going to show you how to write numbers in scientific notation and how to convert numbers from standard notation into scientific notation. So let's begin. First off, scientific notation, a couple basics. The first number in scientific notation is sometimes called a coefficient, and it is a number that, while being positive or negative, it's allowed to be either one, will be a number that is 1 or more, but less than 10. So there's a series of numbers that it could be, 2s and 3s and 5s and 9s, including decimals, but it cannot be 10 or more, and it can't be less than 1. There is always going to be a times sign, sometimes a dot, sometimes an X. There will always be a base 10, never anything besides base 10, and there will always be an exponent, and this exponent will always be an integer. All right, integers are whole numbers that are positive or negative. If your integer is positive, that means your number is going to be a big number. If your integer is negative, that means your number is between 0 and 1. That's essentially a small number. So I have 6 examples that we're going to work through to keep this video short. And I want you to observe right away that I have what I would consider to be a big number and a big number. Those should get positive exponents. I have a number down here that has a positive exponent. That is also going to produce a big number. Then I have small number, and a negative exponent. Those 3 are going to go together as examples of small numbers. So I'm going to leave them grouped like that, but now what I'm going to do is I'm going to put them into the format where my number is between 1 and 10 times 10 to some power. So let's check this out. First and foremost, I can do the easy part first. I'm going to place a decimal where I want it to go. Now, in order for my decimal point to make the 45,000 in the upper left-hand corner between 1 and 10, the decimal has to go here. It had been at the far right-hand, it had been here, but we want it to go here. I'm going to make it really big and obnoxious. Upper right-hand corner, it used to be here, we want it to be here. In the next one, it used to be here, we want it to be here. It used to be here, we want it to be here. Right? There's a little bit of skill involved in putting your decimal in the right spot. So let's address that right now. We're going to do that using the purple pen. Now watch. I'm going to take my original decimal and I'm going to move it to end up where I want it. 1, 2, 3, 4 places, right? 4 places. I'll do this again. 1, 2, 3, 4, 5, 6, 7, 8 places. 8 places. In this one, 1, 2 places, but you notice that this is a small number, so the 2 is going to become negative because I'm moving it the other way. Same thing here, 1 place, but moved the other way, so -1. Now, that number that you just wrote down is the exponent above the 10. Makes it really, really easy. Each problem gets a times, and the number that you have, 4.5, is what goes in front. 8.41 goes in front. 1 goes in front. 1.49 goes in front. And you're done. Right? That's all there is to writing numbers in scientific notation. If your teacher decides to try to trick you by making one of the numbers negative, just make your number negative. Piece of cake. That's all it takes. Now, the only other thing that can really be done at this level with scientific notation is to give you numbers in scientific notation and have you write them in standard form. Piece of cake. We're just going to reverse the process. We have a number, 8.4, and if I mark with my orange, this is where the decimal ended up. But it had been moved 3 spaces. So let's reverse the movement, right? We want a small number here. So 1, 2, 3. That's where it started. I need some placeholders, and we're done. All right? 0.0084. That's how you do it. Let's try it one more time. This number right here is 6. The decimal ended up here, but it's a big number, so it must have moved from a previous location. Once again, it must have moved around something, so this number is 600.